So, we have these two stormtroopers, FN 1988 and FN 1990, who kind of fell in love on the Death Star, though they know that everyone in their unit is about to get reassigned, and they will need to move. Ideally, they hope to get stationed together, so we want to know what are the chances of them getting stationed together at their next duty station. In particular, in this video, we will discuss the multiplication rule for dependent events and the addition rule for disjoint or mutually exclusive events. There are 5 stormtroopers in their unit, and they know that 2 of them will go to Naboo, 1 will go to Tatooine, and 2 will go to Alderaan. So they're feeling pretty good about the fact that there are 2 of these 3 locations that will have 2 openings. Ideally, FN 1988 and FN 1990 want to live in Naboo, where they hope to spend some free time riding their bikes around town and enjoying the good weather. If the billets are randomly assigned, what are the chances that FN 1988 and FN 1990 will get to live together in Naboo? There are a lot of ways that we can think about this problem, though I want to start by using a tree diagram. Not a love tree, though a tree diagram, to figure out all the possible ways that these 2 stormtroopers could be assigned their 2 duty stations. In other words, I will use a tree diagram to write out my sample space. Let's start with FN 1988's duty location. There are 2 openings in Naboo, 1 in Tatooine, and 2 in Alderaan. Okay, so next let's figure out where FN 1990 will go. This is going to be a little more difficult because it depends on where FN 1988 was assigned. So if FN 1988 was assigned to Naboo, there's only 1 more Naboo opening. There'll be still 1 Tatooine opening, and there'll be 2 Alderaan openings. The same would be true if FN 1988 got the other Naboo position. If FN 1988 was assigned to Tatooine, then FN 1990's options are much different. Remember, there's only 1 Tatooine option. Therefore, if FN 1988 was assigned to Tatooine, then FN 90 will get either 1 of the 2 Naboo openings or 1 of the 2 Alderaan openings. Next, if FN 1988 was assigned to Alderaan, then FN 1990 will have 2 Naboo openings still available, 1 Tatooine, and 1 Alderaan opening available. The same would be true if FN 1988 got the other Alderaan position first. Okay, so that is the complete tree diagram for these 2 stormtroopers, and I can use this tree to write down the entire sample space. Starting at the top, the first possibility is for these guys to get Naboo and Naboo. Okay, so I'll write that down in the sample space. Perfect, that's what they want. The next option is for them to get Naboo, then Tatooine. Naboo, then Tatooine. Okay. The next option is for them to get Naboo, then Alderaan, or they could have again gotten Naboo and then Alderaan. I'll continue to read off this tree and write down my entire sample space. Okay, great. I used my tree diagram to figure out every possibility and write down my sample space. So what's the probability that these guys will get stationed together in Naboo? I can write this down as the probability of N1 and N2, meaning the probability of getting the first Naboo station and getting the second Naboo station. Let's look over to our sample space. It appears that there are 2 ways that both stormtroopers get Naboo. And there are 20 total different ways that these guys could have been assigned to the 5 open positions. So the probability of N1 and N2 equals 2 over 20, which is the same thing as 1 over 10 or 0.10 or 10%. I don't like those chances. Woof. Drawing that tree diagram and writing down all the elements of the sample space was a lot of work. Surely there's a better way. Why, yes, surely there is. It is called the multiplication rule for dependent events. First, let's talk about what are dependent events. Basically, FN 1990's location depends on where FN 1988 goes. Because once FN 1988 has a billet, FN 1990 can't get the exact same billet. So for example, consider if FN 1988 goes to Taltuning. There's only one opening in Taltuning. So if FN 1988 gets that job, then FN 1990 can't go to Taltuning. In general, look at the list of possible locations for FN 1990. You can see clearly that it changes depending on where FN 1988 gets stationed. FN 1990's duty station is dependent on FN 1988's duty station. Okay, so now that we're on the same page about these events being dependent, let's write down the multiplication rule for dependent events. The probability of event A and B equals the probability of event A times the probability of event B given A has already occurred. Remember that in statistics, this bar represents the word given. Okay, so the probability of N1 and N2, or in other words, the probability of these guys getting the first Naboo job and the second Naboo job, equals the probability of N1 times the probability of N2 given N1. Okay, so the probability of N1, or the probability of them getting the first Naboo job, if we look over here to the listing of jobs, we see that there are 2 Naboo options out of 5. So we have 2 out of 5. Multiply that by the probability of getting the second Naboo job given that one of the Naboo jobs was already selected. So one of them's gone. Now there's 1 left out of 4. Okay, so if we multiply these, we get 2 out of 20, which is 1 out of 10, which is 0.010, or in other words, 10%. Which is exactly the same as what we found when we used the tree diagram and the sample space. Still not looking good for these guys. 10% chance of getting to be together in Naboo. Okay, so maybe you guys need to be a little less picky. what are the chances of getting to be together in general, no matter what the location is? Basically, these guys can get stationed together in Naboo or Alderaan, since both these locations have 2 openings. Looking over at my sample space, I can see 2 possible events of getting stationed together in Naboo and 2 possible events of them getting stationed together in Alderaan. So that is a total of 4 out of 20 total possible events in the sample space. 4 out of 20 is the same thing as 1 over 5, or you could write this as in the decimal as 0.20 or 20%. The chances that they will get stationed together anywhere is twice that of them getting stationed together in Naboo, though still 20% is pretty small probability. Poor guys. It's hard to be a stormtrooper. Again, to find that probability of them getting stationed together in Naboo or Alderaan, we used the tree diagram and the sample space, which was time-consuming to construct and think all the way through. Surely there's got to be a shortcut. Why, yes, surely there is. It's called the addition rule for disjoint or mutually exclusive events. First, let me explain what are disjoint or mutually exclusive events. These are events that basically cannot occur together at the same time. So here, if both guys get stationed together in Naboo, that's one possible event, or they could get stationed together in Alderaan. But it's impossible for them to get stationed together both in Alderaan and Naboo at exactly the same time, right? It's one or the other. So these events are mutually exclusive. Okay, so what's the addition rule for disjoint or mutually exclusive events? We can write this down as the probability of event A or B equals the probability of event A plus the probability of event B. Okay, so how do we use it here? So basically, we want to know the probability of them being together in Naboo or together in Alderaan. By the addition rule, this is the probability of them being together in Naboo plus the probability of them being together in Alderaan. Well, we can write the probability of them being together in Naboo as the probability of N1 and N2, which means that they've got the first and second job in Naboo. And we can write the probability of them being together in Alderaan as the probability of A1 and A2, which means that they got the first and second job in Alderaan. Using the multiplication rule, we can write the probability of N1 and N2 as the probability of N1 times the probability of N2 given N1 has already occurred. And similarly for Alderaan, we can write this as the probability of A1 times the probability of A2 given A1 has already occurred. Okay, let's do this one piece at a time. So the probability of N1 of getting the first position in Alderaan, if we look over here to the list of possible locations, the probability of N1, there's 2 N's out of 5. 2 Naboo openings out of 5. Okay, and then multiply that by the probability of getting the second Naboo location, given that 1 has already been selected. So that's 1 out of 4. All right, next let's do the same thing for Alderaan. So we'll add that, there's the addition, and we'll add that to the probability of getting Alderaan. There's 2 Alderaans out of 5. Times the probability of getting Alderaan, given that 1 Alderaan has already been selected. So if 1 is selected, you have 1 left over out of 4. All right, so we can do some math here, and 2/5 times 1/4 is 2/20. Okay, again, 2/5 times 1/4 is 2/20. So in other words, 1/10 plus 1/10, which is 2/10, which is 1/5, or 0.2. So there's that 20% chance that we found using the tree diagram and sample space.